In this video, we will go over the Bridgewater State University Observatory MaxIm DL image calibration procedure. We will basically be following the steps on this list, but you'll get a chance through this video to see how my decision-making process works when I'm going through the files and what I ultimately do and do not choose to do when we're dealing with particular data files or particular calibration images. We probably won't get through this entire list of instructions in one video. We will initially concentrate on making sure that we have all of the calibration files that we need and calibrating the flats. So to begin, we'll open MaxIm DL6. Let's close this FITS header window for now. And we will be working within the Observatory's 2015 database from our Apogee Alta U47 camera. Let's see, so in, 9/27/2015, so September of that year, we took some shots of the Ring Nebula and of M92 that have not been calibrated yet, or at least not adequately. So we have blue, clear, red, and green. And these are photometric filters. We have the same filters with M92. We also appear to have darks and flats. Maybe not. So every once in a while something goes wrong during the flat imaging procedure and things like this happen where we end up not having flats from that night. That's okay. We do need flats, preferably from that night, but from a previous night is okay. All right. So the previous day, we do have clear flats, which we need to calibrate the clear images of the Ring Nebula and M92. Let's see. We have blue flats, red, and green flats. That's good. So first, let's find out what the quality of these flats are. I'm going to start in the clear. So I will select all of those and I will drag them in to MaxIm DL. As I dragged them in, I was furtively taking a look at this screen stretch window over here and seeing if the numbers displayed in the minimum and maximum windows are what I would expect for flats, and they are. So the maximum value that ever could be recorded here is approximately 66,000 counts. That's how many times a photon interacted with the pixel. At least it is for us because the gain is 1, basically. We want to see that the numbers at this peak in the screen stretch histogram are about halfway, and they are. Half of 66,000 is 33,000, so great. Is it that way for each one? Let's take a look. Yes. A little high. That's not too bad. We're starting to get a little low here, so we're going to have to take a careful look at these files. I'm going to change the screen stretch to range. And we want the peak to be somewhere around halfway, but there are some hard limits on where this minimum and maximum number can fall when they are representing the dimmest pixel, which would be here, and the brightest pixel, which would be here, contained in the flat image. So a flat image is supposed to be an evenly illuminated one. So ideally, if this image were perfectly flat, all of these pixels in here should be the same amount. They are not, because there are various reasons why a pixel is not going to record the same level of brightness, even if it is looking at an object, in this case the twilight sky, that is completely even in brightness. So one of those reasons is that the center of a telescope's image is always brighter than the outside of a telescope's image. That is normal and is a consequence of the optics. That's called vignetting. You don't see too much of that in this image, but you can sort of tell. This middle part here that I'm circling is brighter than, say, this corner on average. There are also the dust donuts. So these are actual particles of material that are somewhere in the optical system. They may be on the window that protects the camera's sensor from the elements. They may also be somewhere else in the optical train, on one of the mirrors, something like that. And you can get different size donuts depending on where they are in the system. You can see at this point we had lots of dust somewhere in the system. You also see this crosshatch pattern, which was a problem for certain CCDs depending on how they were manufactured in the past. The cutting process left a pattern that was primarily revealed by short wavelength photons of light, like in the ultraviolet and blue and the spectrum green as well, maybe. It mostly disappears when you're looking in the red and infrared portions of the spectrum, and then you get other issues that come up instead. Regardless, these are all things that mean the camera, even when presented with a perfectly even light source, does not produce an image that is perfectly even in brightness. Instead, you get this. And how well this represents the camera's deviations from normal is the point of taking these flat frames. We take more than one because each individual image is going to have some variation, and by averaging them or using a median combine method, we can remove at least some of that deviation, which would cause extra noise in our pictures. The reason that we want these numbers here for the dimmest pixel and the brightest pixel to be within a certain range is because if the image is too dim, then noise that comes from sources like heat and electronic noise start to dominate the image more. So it's like you would be taking a picture of these dim things that you're not interested in, electronic and thermal noise, rather than taking an image of the deviations from average brightness, which is the point of the flat. You also don't want pixels to be too bright, because beyond a certain point, the camera is not going to respond linearly to light. So up until at least halfway, every time one photon of light strikes a pixel, it should be causing one charge to build up, one electron, 1-to-1 ratio. But at some point when we call it a well, it's an electron trap, the pixel gets too full of charge, it is statistically less likely that a photon of light is actually going to interact and cause an electron to be trapped. Okay, so we have this set of flat images, and we need to figure out which ones are within acceptable brightness ranges. I limit the minimum brightness to 22,000 counts, so anything that drops below 22,000 I reject. Anything above about 38,000 here I am wary of. I may accept it if there are very few flats that would otherwise be acceptable, but I'll usually reject them. So this one is easily within that range. 24 to 29,000, that's fine. So I'll close that one. That one's all right. This one looks like it's going to be high if I switch it to range. Yeah. So that 43,000 is well above 38,000. I'm going to minimize that. And I'm also able to click R if I have this screen selected, so that I can more easily switch to this range way of looking at the brightness values. This one's all right. That one is not. That one is below 22,000 at minimum. That one's all right, so I close it. Good. Close. Good. Close. Good. Close. Good. Close. Good. Close. Good. Close. And good. Close. So there are only two that didn't make the cut, potentially. But I'm not done with my decision-making process yet, because it's important also to have enough flats that deviations from image to image average out. So let's take a look in here and see how many there are total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so if I cut out these two flats, I still have 10. I really like to have a minimum of 10 flats. 12 would be better, but I don't have 12 that are great. So, number 31 is going to get moved to this new folder, and number 21 is going to be moved to that folder, which I will then call bad. The reason I'm not deleting them is because I'm not the only person who uses these files, and I also need to know what I accepted and rejected later if I want to use it for some reason in a publication. So I keep everything, but I also am clear about what I rejected. Alright, now I can close these. So I have these clear flats that are alright. I'm going to open them back up. I'm now going to hit Control F, which brings up the FITS header window. This gives you all sorts of information about the files, including some highly important things. So we want to know the temperature of the camera when these images were taken. So the set temperature, the temperature it was supposed to be at, was negative 10.3 degrees Celsius, and the actual temperature, CCD temp, was also negative 10.3 degrees Celsius. So that's fine. It's a lot warmer than I would recommend setting it to, but that's okay. That's what we have. We also have the exposure time, which was 1.8 seconds. I'm also going to scroll down and see if there's anything that says history down here, which would mean that this image had been edited already. I don't see anything. That's good. Oh, I'll mention too. The filter used when taking the image clear is also going to be listed here. So you can use that to double check and make sure that the operator correctly labeled this as C, and they did. Alright, in order to calibrate these flats, we are hopefully going to use darks, which remove thermal signal, that are 1.8 seconds long and at a temperature of negative 10.3 degrees Celsius. Let's look for those. Alright, let's see if there are any in the same date. It looks like there are. Alright, so these claim to be 1.8 second darks. Let's open one, see if it really is. Looks like a dark. Exposure time, 1.8 seconds. Temperature, negative 10.3. Excellent. Now, if you're paranoid like I am, you may then want to open them all up and make sure that they're the same. I'll go ahead and do that. We might as well. And while they're opening, I'm going to keep my eye on the FITS header window and just see if these numbers stay the same. Yep. They all opened up, and there's a little bit of variation in the temperature, but that is normal. It's sort of like cruise control in your car. It's never going to keep it exactly on target, but it will oscillate above and below the target temperature. So that's fine. And if you take a look at them, they should all look very similar. That's a flat. The static pattern will be a little bit different in each of them, but they essentially look identical. Okay, cool. Now I'll close all the darks. Close that. You can do Alt-F-E to close everything, but I want to keep my flats open for the moment, so I'm just closing all the darks. Okay, so we have found these 1.8 second darks that are the same temperature as our flats and that are the same exposure time as our flats. So we can use those to calibrate them. To do that, we go to Process, Set Calibration. That's fine, that's because I move stuff around. Okay, I am first just going to make sure that nothing else in here is checked. As you can see, I've calibrated a lot of files. Let's get rid of that. Okay, looks like that was all. I am going to select Dark in the drop-down menu, and I'm going to hit Add Group. And I want to name that group something that is recognizable. So let's see, we're on 9/26/2015. In here, so they stay in order, I'm starting with the year, though. 2015, 09, 26, dark, and 1.8 for the seconds. Okay. And the easiest way I find to set this up is to just select all of the files that I want that are the darks that are 1.8 seconds long and at the temperature that I want, and just drag them into this bottom window here. You can also click this Add button, but then you have to re-navigate through Windows to find the files in that menu, and I find that to be irritating, so I don't do that. Okay, so the calibration window gives you information as well. Duration, 1.8 seconds. Great, it matches. Temperature, -10.3. Awesome. That's what we want. The reason that it's good to check that, just in case somehow you managed to grab the wrong files, well, you would be able to tell in here that you had done that. In here, very rarely do we want to use any dark frame scaling where it multiplies the numbers for the pixels, so the brightness of each pixel, by some scale factor. Usually you don't want to do that. We may end up needing to at some point, but for now, we're going to say none. Combine type, I almost always set that to median. So what that does, rather than averaging, say, the very first pixel in the top left corner of one file with the very first pixel in the top left corner of all the other files, which would keep any very strange or outlying information. For example, if a cosmic ray happened to strike the sensor, it would keep that. It would still be part of the information that we used to make our calibration files. By choosing median, we reject any outlying things like that, and instead keep whatever value for this top left pixel that is the middle value. So you end up not including anything really weird in your final calibration at all, and I prefer that. It's also great at just minimizing noise. The other options are averaging, which again would keep that information, Sigma Clip, and SD Mask. SD Mask is processing heavy. I have never found it to do a better job than median at reducing noise. Sigma Clip ideally should be sort of a combination of median and average, where first the software looks for pixels that are overly bright or overly dim, then rejects them, then averages the rest of them together. So you'd think that that would be as good as, if not better, at making pictures less noisy than median. But for some reason I found that sometimes MaxIm DL bugs out and doesn't actually do the calibration if you choose Sigma Clip. We discovered that when we had some issues with noisy files, going back and trying to figure out why. So I stick to median. We don't have a bad pixel map. So we'll click Advanced and make sure that all of these are checked. Hit OK, and then OK again. Now I go to Process, Calibrate All. Okay, it doesn't look like it did anything, does it? But it did. Look. Here's my screen stretch menu, which shows you the minimum and maximum brightness here, and maybe I should set that to range to make it a little more obvious. And if I click on this image and do Control Z to undo the calibration, let's try that again, and Control Y to redo it. That's irritating. Undo. There we go. Undo. Redo. You see? The numbers are changing. And they've gone down. So if I undo again, the minimum was above 22,000, but then I redo it, and now it's below 22,000. So that minimum number has reduced by about 1,000, which makes sense because if I open up one of these darks here, look at the values. About 1,000. for how bright the pixel values are. In other words, this dark pattern, a representative dark pattern made by combining all of those dark images that I just used, was subtracted from this image, well, yes, from this image, and then redo to make the new one here. It doesn't look different, but the numbers are different, and that thermal noise has been removed. Statistically, some of it is always going to be left, but there it is. That's a calibrated flat. And they're all calibrated, because I checked Calibrate All here. Now we want to save it. We never want to hit the save button, because that just overwrites your original files, and we never, ever, ever want to do that. So we will say File, Batch Save, and Convert to save all of them at once elsewhere. We select images, add all, OK. So now all the images that are open here are selected. File format, fits, size format, float. No auto stretch. We don't want to change any of the information in the image. We're going to add the _cal suffix to the end of the file name so that we can tell later which files we calibrated and which ones we didn't. And then we're going to choose where to save it. So I am currently in our database, which is in the OneDrive here. So the observatory data backup, 2015, and we were in the day September 26th. There it is. We were doing the clear flats, see? So clear. I select that folder and I click this icon to make a new one, and I'm going to name that new folder Cal. And I'm going to click OK. We already calibrated, so I'm not going to do this. You can use this if you want to quickly perform calibrations when you're used to the process, but for now I'd absolutely recommend always watching it to make sure nothing weird happens to your images when you calibrate them. And I always choose, if destination already exists, move to subfolder backup so I don't accidentally overwrite any files or fail to save them. Click OK, and it will save them all. And if I go in here, flats, clear, cal, there they are. Now to close everything at once, because I'm done calibrating these clear flats, I hit Alt-FE. I am going to do this same process to the other colors of flats in this folder. So this was taken through a luminance filter, Astrodon, infrared blocked. Looks like I calibrated these once before, but we'll go ahead and redo it for the purposes of the video. So these are the blue flats. Let's take a look at these, taken through an Astrodon photometric blue filter. Okay, again, this looks like it's about at the right brightness level. I click R. Yep, we're above 22,000 and below 38,000, so that's fine. 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 Yep. Good. 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 And good. All right, so all the blue ones were good. We didn't have to reject any of those. I'm going to drag them back in. Hit Control F to take a look at their properties. The exposure time was 1 second on these, and the temperature again was negative 10.3 Celsius. So we want 1 second darks. So I just went up to the base folder for that date, September 26th. I'm clicking on darks. We have a folder labeled 1 second. Let's see if those are, in fact, what they claim to be. So I'm watching the FITS header window while they open. Yep, They all remained 1 second, and this fluctuated slightly different from negative 10.3, which is acceptable. Alt FE, close them all. Oh, no, I closed them all. Well, that's all right. I'll make my calibration setting first. I will go to Process, Set Calibration. I'm going to uncheck that because I don't want those darks from the last batch of flats. I'm going to add a new dark group. I will label it 2015-09-26 dark 1 for 1 second. You could do 1S. That would work as well. And I'm just going to drag my 1 second darks that I just looked at into the box. These settings are all still the same. Those are all still checked. I click OK. And now I'm going to find those blue flats again. Open them up. Hit Process, Calibrate All. And if you watch, I don't know if you were watching, I'll undo again so that you can see, undo, redo, that the numbers did change again. So these are calibrated. We need to save them. We go File, Batch Save and Convert, select Images, Add All, OK. The format should be Fits, Size Format, Float, no stretching. The suffix should be _cal. For a path, these are the blue flats, so we will select the blue folder and make a new one under it that also says cal. Okay. And we're going to move to a subfolder if we would overwrite something, and we're going to click OK. And now if I check, I now have a cal folder in here for the blue flats, and here they are. Alt FE to close everything. I'll do that one more time. Now we have red flats. I'm going to open them up in MaxIm DL6. I am going to check their brightnesses. So I click R. That one is in the acceptable range of 22,000 to 38,000. So is that. Let's move this because that's a little inconvenient. Close. Good. 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 And good. So those were all in the acceptable range. I will point out they were all a little bit low here. They were near the minimum, so they may be a little, the product of them may be a little noisier than normal. Okay. Looking at my fits header window here, the exposure time for these red flats was 2 seconds, and the temperature was still negative 10.3. That one's a little bit far off there. Oh, look at that. Quite a bit of variation. But that's okay. Not too far off. So we are looking for darks that will match these numbers. And I just noticed, actually, this does happen sometimes. So when our operators are taking the flats, they are trying to keep the brightness within an acceptable range, which means if the twilight sky gets too dim while they're in the middle of an imaging run, they will stop and they will change the exposure time for the flats. So if we take a look here, we have 3.29999, we'll say 3.3. This one is 2.4. This one is 2.8. 2.8. 3.3. Was that the same as this? Yeah. All right, 3.3. 2, which is the first one that I saw. 2, 2, 2, and 2. So just in case that was confusing, the number I was looking at was the exposure time. For these it was 2. For these it was 3.3. For these it was 2.8. And for these it was 2.4. That may actually explain why we had such a big difference in temperature. Are the shortest ones the warmest ones? They are. Okay, so fun fact. This is what happens when something goes wrong during the setup procedure and the operator is hurrying to take flats in time. So the camera was probably not quite all the way cooled down when they first started to take these. Probably. There could be other explanations too. So we have 4 different exposure times. That means that we need 4 different sets of darks just to calibrate this one set of red flats. This is where it gets a little tricky. So, it looks like we don't have any 2-second darks from this date. We might have some from a different date, but not this one. These were 3.3. We have that right here. These were 2.4. We don't have a 2.4. And this was a 2.8. We do have a 2.8. All right, so we have a 2.8 and we have a 3.3. We don't have the other two. So we have a couple choices. We can use the closest available exposure time and bias files to calibrate the flats for which we don't have an exact match. Or we can go hunting through other dates, not September 26th, to try to find darks that exactly match those times. I'm going to bet we probably have some 2-second ones. 2.4, it's a little more unusual. Less likely. It might be good for you to see the bias procedure anyway. So here's what we'll do. First, I'll calibrate the ones that match exactly, and then we will go through the procedure to calibrate something when the exposure times do not exactly match, using biases to scale the dark frames. Okay, so let's see the exact matches. 3.3. We have that. Let's just quickly make sure that it's still negative 10.3. Yep. Okay. So I'm going to go to Process, Set Calibration. Going to uncheck the previous group and add a new dark group. And label it 2015, whoops, 2015 09 26 dark 3.3. And I will drag these in to make that group. Since I'm already in that window, and you can do this, you can put both in at once, I will also add another dark group. 2015 09 26 dark, I already forgot, 2.8. Here we go. And I will drag these in here. Both groups are now made. I'll do the 3.3s first, so I'll uncheck the 2.8s and click OK. I don't want to hit Calibrate All, because that would calibrate all of these using flats, darks that were only correct for some of them. So I'm not going to do that. Instead, I will find the 3.3s. There's one of them. And I will click Process, Calibrate. This was the other 3.3? Yes. I will click Process, Calibrate. So now my two 3.3s that I had should be calibrated, and I can confirm that if I scroll down on the Fits Header window and look for a history. There it is. Dark subtraction, and it's even nice enough to tell you which dark group was used to calibrate it and some basic information about it, like its temperature and exposure time. Cool, although I notice it does round the exposure time. It's worth me checking process set calibration to make sure. Okay, the actual duration was 3.3, so the FITS header window is rounding. Say okay. Alright, so these two are calibrated. I could either save as and get them out of here, or I could wait and batch save and convert everything together when I'm all done. I don't want to get confused, so I'm just going to save them now and close them. So File, Save As. Never save. That will overwrite. Save As. Okay, and it actually recognized where I got these from. Cool. I will right-click to make a new folder. Cal. Go in there, and I will add _cal to the end of the file name. That one's the one that I just saved, which you can see there. The file name has changed. I close it. File, Save As, same deal. I'm already in that folder, so I'll just add _cal. Alright. Makes it a little harder for me to forget which ones I've already done if they're not there. Okay. The 2.8s, I believe, were the other ones, yes, that I already had darks for. So, let's go to Process, Set Calibration. Uncheck the 3.3 darks, and check the 2.8 second darks. And you can see it says the duration is 2.8. Great. Okay. And just for these two, this says it's 2.7999, basically 2.8. I will go to Process, Calibrate. Let's drag that up there. This one is also 2.8 seconds. I will drag that up there. Process, Calibrate. And just to confirm, yes, dark subtraction was done. And I will save them as before. Okay, almost done with the reds. So now we have this one, which is 2.3 seconds of exposure, 2.4, and this one, which is 2, and these are all 2, so there's more 2s. Now let's get this one out of the way first. Let's see if we can find what's closest to the 2.4. 2.8 is only 0.4 seconds away from that. That's pretty close. Although I tend to find that scaling up works a little bit better than scaling down. Let's go into my calibration window here. I already have the 1.8 second darks set up. Yeah, it's a bit of a toss-up between the two. Do I go down or up? I usually find that going up, scaling upward, works a little bit better. So I'm going to check the dark 1.8 since these two are pretty similar in their distance to 2.4 seconds. And I am going to scale them, but I can't. It won't let me select that yet because I don't have biases chosen. So I'm going to click OK for the moment. Now I want to find bias files that are at a temperature of negative 10.3 Celsius. And that can take some clicking because biases don't need to be taken every night at all. They are only typically taken whenever the temperature of the camera is changed. Ah, here we go. Or sometimes when you have an operator who just feels like taking biases. So, let's see. What are these? Negative 10.0. Wait, that's a little off of 10.3. Let's see. I bet the setting was 10.3. But let's see if some of them later are more on target. It's a little closer. I'm probably just looking at the natural oscillation All right. They're a little bit on the warm side on the whole. Yeah, I don't know if those are ideal. I'll use them if I have to. I'd rather have ones that are closer to negative 10.3. Don't want to close my flats there. All right. Again, I'm searching for biases at a temperature of negative 10.3. They don't have to be too close in date to the date that the data were taken. Closer is better, but within 6 months, I've read various places, is okay. Flats. Darks and biases. Those are on the warm side. Well, that one is. Let's see if all of them are. Oh, also a little bit on the warm side. Okay, well, if they're all going to be like that, might as well use the one that's closer in date. Okay. So that was right around there, September 24th. So these are the biases that I'm going to use. I go to Process, Set Calibration. I'm going to leave that checked because I still want to use those darks, but I'm also going to add a bias group. And I'm going to name it 2015 0924 bias. Oh, I must have used him before, but that's okay. 2015 09 26 24 biases. I probably didn't do that. There we go. For the purposes of the video, I'd rather make the new one. Okay. We will select one of those and hit Control A to choose all of them. Drag them in. So this gives me the average temperature, and it is a little on the warm side, negative 10.11 instead of negative 10.3, but it's not too bad. And the duration, there shouldn't be one. Biases are 0-second exposures. The camera is given no time to build up a charge. That's how it is a representation of electronic noise, because you shouldn't actually be receiving any light for a duration of 0 seconds. So these are used to remove consistent errors, consistent noise in the images that is there regardless of how long the exposure is. That's why you have to remove them from something like this, from a dark, if you're going to multiply it to apply it to a flat or a data image that is of a different length, because this noise, this is constant. That does not increase with exposure time. So if you left it in there and then you multiplied it, you would be increasing this, but it's not increased in the flats that we're going to calibrate. So it would actually be incorrect. You'd end up subtracting too much of this signal out, and you would cause extra noise in your final calibrated flat image. It needs to be removed if this is going to be scaled to be applied to an image of a different exposure length. So now you see I have the option, dark frame scaling. Yes. Auto scale, please. Everything else remains the same, though. And only this and that should be checked. Let me just make sure. Yep, nothing else is checked. Those are all still checked. Okay. Alright, so that was the 1.8, which... Actually, that's close to either of these, to the 2 or the 2.4. Maybe we can just get away with doing all of them in one shot, since we don't have 2.4s either. We don't have 2.4s and we don't have 2s. So let's just go ahead and say process calibrate all. It's thinking about it. It has to think longer when it does more math. It's removing the bias signal first, and then it is averaging the darks together, and then it is also applying the bias separately to this because the electronic noise was still in this. Okay, we hopefully now have calibrated flats. If I look here, actually if I look here on the history, it's now a little bit more complicated. Instead of just dark subtraction, there's both a dark subtraction line and a dark bias. So that we know that we did both to this one. And if I look here and hit undo, the numbers change again. So I can see that it was altered by calibration. Since I have a bunch of them to save at once, I will do File, Batch Save, and Convert. Select images, add all. OK. Fits, float, none, underscore cal, and I choose my path to save it. Again, I'm doing red flats, and I already made the calibrated folder, cal, for those red ones. So I'm going to click that and hit OK. And OK again to actually save them. And now when I go into that folder, that was September 26th, flats, red, they're all there. Hooray! Alt FE to close everything at once. Now the red one was much more complicated because there were multiple exposure times and because some of them didn't have darks that exactly matched the exposure times. And that's an example of why seeing somebody's decision-making process can be really helpful in learning how to calibrate these files properly. It would be great if we always had files that matched, but we just don't. Since that one was pretty complicated, it's probably worth taking a look at the green ones and seeing what that's like. All right. We have 1.8s, 1.8, 1.8, 1.8, 1.3. More 1.3s. All right, there are 2 exposure times for the greens, 1.8 and 1.3. And I'm curious to see if we have darks that match. There's the 1.3, there's the 1.8. Okay, so for the greens, it's not going to be as complicated. We might as well go ahead and do it for one last shot of practice here, or review on this video. So again, our temperature is negative 10.3. We have 1.3s and 1.8s. Now if I remember right, if I go to Process Set Calibration, and I scroll down, I don't need these because my exposure times matched. Yep, 1.8 was what I just used, so I already have 1.8 set up, so I may as well just use it. I'm going to say no to dark frame scaling, and I'm going to click OK. Alright, so this is 1.3. I'm just going to minimize the 1.3s for now because I only want the 1.8s. There's 1.8, 1.8, 1.3, 1.8, 1.8, 1.8. Alright. Oh, and before I forget, I'd better make sure that they're all okay. They look okay, but let's just make sure. And I do that again by using the screen stretch window, clicking R to make sure that these numbers are between 22,000 and 38,000. Yes. 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 Awesome. I love it when it works out like that. Okay. And now for each of these individually, I'm going to hit Process Calibrate because I do not want to calibrate these other ones down here yet. Process Calibrate. Process Calibrate. Process Calibrate. Process Calibrate. And Process Calibrate. Okay, and again, if I scroll down here, yes, I have a history of dark subtraction, and I should see that for all of them if I check. There it is. Make sure that I did it. And once you get good at this, you really don't need to check every single time, but it's good to verify. Okay, so these 1.8 greens are calibrated, and now these, let's restore that, were 1.3. So let's find 1.3 second darks. Here they are. And here's what you can do once you're sure what you're doing as well. Go to Process, Set Calibration. You notice I didn't bother opening the darks to check them. Dark, I'm adding a dark group. 2015, whoop, let's try that again. 2015, 09, 26, dark, 1.3 seconds. Here they are, just going to drag them in. And duration 1.3. I can verify that that's the exposure time here, because this will show you the average, so if one of them isn't 1.3, it'll look different. Temperature, negative 10.3. Good. If you still want to open one of them to make sure it actually is a dark, that's not a terrible idea, because every once in a while mistakes are made. Hit OK. I can do that here just to verify. Yep, that's a dark all right. And actually, image type, dark frame. It even says so in the FITS header window. Alright, so my darks are set up, so now I can calibrate the others. I could actually hit Calibrate All and it would do all of these and give me error messages about these, but I won't do that. I'll just hit it individually. So Process Calibrate. Oh, I should have checked my range here. Looks like it's fine anyway. That one's good. Process Calibrate. That one's good. Process Calibrate. Range. Yes, we're in a good range. Process Calibrate. Check the range. It's good. Process Calibrate. Check the range. Oh, just makes it. But it's still good. So Process Calibrate. What about you? Oh, you're in there. Oh, all right. Okay. So Process Calibrate. So now I have a bunch of calibrated flats. This is the only one that's not in range. Just make sure, yeah, we look good. And I can hit Batch Save and Convert and save them all at once. File. Batch Save and Convert. Add all. Fit. Float. None. Underscore cal. Choose my path. I want the green folder, which is V. I know that seems weird. That's what it's called. So I made a cal folder under V. I hit OK. Hit OK again, and it will save them all. And if I double check, I'm in the green folder for flats. Here's cal, and there they are. Now that entire process was just to calibrate the flats, which I then am going to turn around and use to calibrate the actual data images that are in this folder, which I don't know if you remember even what they were. Oh, that's right. So we went back to this date because there weren't any usable flats in the original folder I checked, which had pictures of the Ring Nebula and M92. Has the moon, but that's probably for another time. So we didn't even get to the data yet. That was just preparing the calibration files to be used on the data, which is why I'm going to leave it off there. And the data itself will be for the next video.